Audible? Good morning. No one is responding. Is it audible?
Yes.
Yeah.
Yes, sir.
Okay. In the last class, as we are discussing about the types of polymerization, there are three types, ma. What are the three types of polymers? Okay, as we are discussed about the three types of polymerization, one is addition polymerization. Example for the addition is polyethylene, polyvinyl chloride, and polystyrene. Condensation, nylon 66, copolymerization. Okay, copolymerization, we are going to discuss about the bakelite. We will discuss one by one in the preparation. Okay, coming to the addition. Addition is nothing but who is that?
Good morning, sir.
Good morning. Good morning. Okay, we discussed about the addition polymerization or chain polymerization. Here, this is nothing but the yield of the polymer product, which is the exact multiples of monomers. Okay, whatever the monomers we have taken, the same number of polymers will be present in the polymer. Monomers, the exact multiple of monomers is the polymer here in the addition polymerization. There are no byproducts are formed in the addition polymerization, and the molecular weight of the polymer is exact multiple of monomer. How much the monomers will take? Okay, the same amount of the polymer will be the product in the addition polymerization, and during the conversion of this pi bond to sigma bond takes place during the polymerization. It liberates a 20 kilocalories of per mole of energy, hence highly exothermic reaction. These are highly exothermic reaction. Coming to the examples for the addition polymerization is here polyethylene. Okay, polyethylene and polyvinyl chloride. Okay, polyethylene, polyvinyl chloride, and polystyrene. Example: ethylene is a monomer. These are the presence of heat pressure as a catalyst produces polyethylene, polyvinyl chloride. Okay, on the ethylene, if you replace the 2 hydrogen with Cl, you will get the replace the sorry, 1 hydrogen with Cl, you will get the vinyl chloride. That is on this. This is on polymerization. It produces the polyvinyl chloride, and the styrene on the benzene ring. If CH double bond CH2 is present, it gives the it is under. Okay, this is nothing but styrene. Styrene on polymerization, it produces the polystyrene. On polymerization, it produces the polystyrene. Coming to the condensation polymerization or step polymerization, what actually is condensation? Okay, we are condensing the two monomers. Two monomers on condensation produces the polymer. Here, the condensation reactions of functional groups of monomers with elimination of byproducts. Here, elimination of byproducts takes place. We have taken already the example of nylon 66. Nylon 66, we are taking the adipic acid. Adipic acid formula is COOH, CH2 taken 4 times. Okay, this is the formula. Adipic acid CH2 taken 4 times plus COOH, the formula for adipic acid. Adipic acid reacts with hexamethylene diamine, NH2 hexamethylene. Okay, you are taking methylene groups CH2 6 times, hexamethylene diamine. Yeah, Vaishnavi. It produces in the presence of it eliminates the byproduct. The byproduct is NH2. Sorry, H2O is a byproduct. It produces the nylon 66. Nylon 66 is the product here. See the condensation polymerization or step polymerization. We are taking the adipic acid. Here the removal of H2O takes place. OH, you will get adipic acid reacts, condenses with hexamethylene diamine by loss of 2 moles of water molecule. This is a byproduct. It produces the nylon 66. Nylon 66 is the product. Okay, this is prepared from condensation polymerization. Nylon 66 is prepared from condensation polymerization. Okay, what are the uses of nylon 66? Nylon 66 used in the uh, uh, pictures. Okay, pictures of nylon 66 in the threads, making the nylon threads, and nylon cloths are prepared by using this nylon 66. Okay, coming to the copolymerization. Okay, it is prepared by copolymerization is the joint polymerization of two or more monomer species. Okay, when two or more monomers are joined together they form the polymer, that is copolymer. Here the example we are taking in the preparation of nylon 66. Okay, this copolymer is butyric rubber. Okay, butyric rubber and tricol rubber, they are prepared by copolymerization. Here butadiene, 1,3-butadiene or butadiene. Formula for butadiene is CH2 double bond CH double bond CH2. Okay, on the first position the double bond is present, so we call first 1, 2, 3. On the third carbon we have again one double bond, 1,3 butadiene. 1,3 butadiene reacts with styrene. Here it is double bonds are present. Styrene reacts with styrene, it produces, okay, butyric rubber. Okay, in the presence of sodium metal, heat under pressure on polymerization of this 1,3 butadiene and styrene, it produces the polymer, that is copolymer. This we call, this is prepared by copolymerization, nothing but butyric rubber. Butyric rubber. Okay, it is nothing but the monomers involved in the preparation of butyric rubber is 1,3 butadiene, 1,3 butadiene. Okay, monomer is 1,3 butadiene and styrene. These are monomers. These are copolymerization. Okay, joined together to form butadiene styrene or copolymer butyric rubber. Okay, the product is CH2 single bond CH double bond CH CH2 CH. Here benzene will be present. Butyric rubber. It is a polymer chain. Just we are representing in the form of N. Polymer. Butadiene or butadiene styrene copolymer butyric rubber. It is prepared by joint polymerization of two or more monomer species. Okay, these are high molecular weight compounds obtained by copolymerization are called copolymers. Butadiene and styrene copolymerize to yield GRS rubber or butyric rubber. Okay, it is prepared in the, okay, shoes are prepared by this butyric rubber or GRS rubber. Okay, this is the differences between addition polymerization and condensation polymerization. Okay, monomers must be at least one multiple bond, means it should be contain one double bond. CH2 double bond CH2. Acetylene also it contains CH triple bond CH. Okay, the monomers must have at least one multiple bond monomers. Okay, here in the preparation of polyethylene, we are taking the monomer ethylene. Ethylene on polymerization, it produces polyethylene. Okay, here the monomers should contain at least one double bond. Multiple bonds are nothing but double bond or triple bond. Here, the monomer must have at least two identical or different functional groups. Already you know that in the preparation of nylon 66. Okay, on the adipic acid CH2 taken 4 times. Okay, COOH. Here the monomer is containing 2. Here the monomer contains 2 identical groups COOH. Okay, here COOH, one COOH and second COOH. It contains the functional groups are identical functional groups. That is the meaning of identical or different functional group. Either it is at least 2 identical or different functional groups. Example, glycol or nylon 66. Nylon 66 is the example for this monomers we are taking. Here monomers add on to give a polymer and no byproduct is formed. Already you know this. Okay, here there is no byproducts are formed in the monomers condenses to give a polymer. Okay, here the preparation of nylon 66 adipic acid reacts with hexamethylene diamine produces the nylon 66 plus byproduct is 2H2. Okay, here byproduct is formed. Monomers condense to give a polymer and byproducts such as H2O, methyl alcohol, etc. are produced with the condensation polymerization or step polymerization. Now coming to the addition polymerization, number of monomeric units decreases. Okay, here number of monomers are decreases steadily throughout the reaction. And go on adding these monomers, it is decreasing. But here it is monomers are disappear at the early stages. The first stage itself. Okay, we are taking what we are taking the monomer like adipic acid and hexamethylene diamine. Okay, the product we got is nylon 66. The monomers are disappearing at the early stage only. At the initial stage of the reaction itself, the monomers are disappeared. That is the meaning of monomers disappear at the early stage of reaction. But here it is not happening like that. Okay, steadily. Okay, whatever we got, the monomer we are taking ethylene on polymerization, it produces polyethylene. Okay, the same it is producing. Okay, the same ethylene, the polyethylene. Okay, it decreases steadily on throughout the reaction. But here at the initial stage of reaction itself, the monomers are disappearing. We are using adipic acid plus hexamethylene diamine. Okay, we got the different that is nylon 66. Nylon 66. That is the reason. That is we called it as the monomers are disappearing at the early stage of the reaction. Now coming to the molecular weight of the polymer is a integral multiple of molecular weight of the monomer. Same. Okay, how many number of monomers we are taking, the polymer is having the same number of molecular weight. Okay, how much weight of the monomer we are taking in the preparation of the polymer, the same amount of polymer will be present here. Here the molecular weight of the polymer is need not be same. Okay, the different, it should be the different. Okay, need not be the integral multiple of the monomer. Now high molecular weight polymers are formed at once. High molecular polymers are formed at once. Here here molecular weight of the polymer rises steadily throughout the reaction. Okay, it slowly it increases throughout the reaction. Here the longer reaction time gives high yield. Okay, longer reaction time it yields high yield, but a little effect on the molecular weight. Little effect on the molecular weight. Here longer reaction times are essential to obtain high molecular weight. Longer time is required to obtain the high molecular weight compounds. Thermoplastic resins. Okay, this addition polymerization. We will discuss the next topic. This thermoplastic. Okay, plastics. We need to discuss this. What is thermoplastics and setting plastics? Thermoplastics are produced here in the addition polymerization by using this thermoplastics. Example, polythene, okay, PVC, polyvinyl chloride, etc. are the thermoplastics are produced in the addition of chain polymerization. Thermosetting plastics are produced. Example, bakelite, urea formaldehyde. Homo chain polymers are obtained. Means same chain polymers, different chain polymers are obtained here. Now coming to the next topic, classification of plastics. Okay, classification of plastics, that is thermoplastic resins and thermosetting resins are thermosetting plastics. Thermoplastic resins are thermosetting plastics. What actually these plastics are? Okay, okay, before we need to know about this thermoplastic resins or thermosetting resins, we need to know the plastics. What actually these plastics are? Okay, how we are going to prepare this plastics. Here plastics are the polymers. Already you know the plastic, rubber, all these are polymers. Plastic are the polymers characterized by property of plasticity. Okay, here it has a property of plasticity, molded to desired form. Okay, we are going to make them in a desired shape. Okay, shape of the desired form. When it will give the desired form when it is subjected to heat and pressure. Okay, as a catalyst. Okay, it gives the It has a property of plasticity and molded to desired form when it is subjected to heat and pressure. Okay, when it is subjected to heat and pressure, it produces in the presence of catalyst. Okay, subjected to heat and pressure in presence of catalyst, it gives the desired form, desired shape of the plastic. Okay, the coming to the term plastic and resins are considered to be synonymous. Both are same. Plastic and resin both are same. Okay, the term plastics and resins are considered to be synonymous. Okay, they give the same meaning. A resin is the product of polymerization. Okay, here whatever the plastics and plastic, you will get the plastics and polymerization, you will get the resin. Resin is nothing but the product of polymerization. Polyethylene, polyethylene is the resin, we call it as resin here. Okay, so how we got this polyethylene monomer? Okay, monomer, that is ethylene, we are taking the okay, ethylene. On polymerization you will get the polyethylene. Polyethylene we call it as a resin. Okay, resin is the product of polymerization and the forms a major product of major part of the plastics, forms a major part of the plastics. Coming to the plastics are materials obtained by mixing, okay, resin with other ingredients. Okay, here how we are going to get this plastics means it is obtained by mixing the resin with other ingredients to impart special engineering properties. What are that, we need to discuss one by one. Okay, what are the ingredients we are going to add to get the, we have compounding of plastics. Compounding of plastics, there we will discuss. Okay, what are the ingredients impart to give the special properties to the plastics, special properties to the plastics. Okay, how we have the a topic that is compounding of plastics. Then we will discuss how we are going to prepare a plastic. Plastics are the materials obtained by mixing the resin with other ingredients. Other ingredients like resins. Okay, we are to give the special properties to the plastics. Okay, this is about the plastics. How they are characterized. Okay, plastics are characterized by light in weight. Okay, these are light in weight. Have the good thermal and electrical. They are good thermal and electrical insulators. Already we have discussed this. Okay, good. Okay, insulators. These are insulators means they does not allow the electric current to pass through them. They are called it as electrical insulators. Okay, plastics are lighter in weight, good thermal and electrical insulators, and have high corrosion resistance. Means these plastics never undergo any corrosion. So we call it as corrosion resistance. High corrosion, they are never undergo the corrosion. Okay, the rust formation does not occur in the plastics. So high corrosion resistance. These are the high corrosion resistance and easy workability. We can mold this prop plastics. We can shape into desired forms. By molding, we are going to shape into the whatever the form we want. We can make the plastic. So easy workability. We can mold the plastics and drilling, etc. High chemical inertness. Okay, they are never undergo the chemical reactions. High chemical inertness, and it requires low maintenance cost. Low maintenance cost.
What happened, sir?
Yeah, it has a low maintenance cost and high abrasion resistance. Abrasion is nothing but a rough surface. Okay, we can easily clean by using this abrasion resistance. Because of this abrasion resistance, okay, it shows that clearness on the plastics, toughness and impermeability to water. Okay, they are not permeable to water, impermeability to water. These are the characteristics of plastics. Now coming to the classification, plastics are nothing but resins. Okay, here it has been classified into two types. Plastics are resins has been classified into two types. One is thermoplastic resin, and the second one is thermosetting resin. Thermoplastic resin and thermosetting resin. What actually this classification of plastics has been classified into two types. One is thermoplastic resin and thermosetting resin. Thermoplastic resin and thermosetting resin. Thermoplastic resins are, okay, these are the resins, those which are soft by heating. Okay, we are going to soft by heating and harden on cooling. Okay, these are the resins that are having the properties like we can make the soft by heating and hard on cooling. They just opposite to this thermoplastic is thermosetting. Okay, what happening means thermoplastic resins are nothing but they are which can be softened by heating and hardened on cooling. Okay, on heating, what we are going to see, it forms a soft, and on cooling, it forms the hard. Okay, due to the action of this heat, okay, the intermolecular forces between the polymer chains. Okay, whatever the forces that have present between the this monomer. Okay, this chains break. Okay, it will break down and facilitate the easy momentum of polymer chain, which makes the this plastic soften. Okay, see whatever the force is on heating. See, this is a picture of thermoplastic resin. Initially, it was okay. These are soft by heating. Okay, it was harder. Initially, it was harder. On heating, what happening? See in the picture, we are heating this thermoplastic polymer. That is nothing but resin. Okay, here whatever the forces are present, intermolecular forces, the bonds present between, that is a weak bonds. Okay, it is undergoing the intermolecular forces. Okay, between the polymer chains are breaking. Okay, it undergoes breakage. Chains are break and facilitate the easy momentum. Okay, on heating, we are applying heating. Here, what happening? The forces present. There is a no links between the polymer chains, so the easy momentum of these polymer chains can be taken place. Okay, see this. This is a thermoplastic polymer. Okay, initially it was what happening before heating. It was hard. This polymer is hard. Okay, why? Because it was hard, because it contains the intermolecular forces. Intermolecular forces are present between the polymer this monomer chains. After heating, it has been undergoing breakage, broken. Okay, this intermolecular forces are broken down, so it will be easily facilitate the easy momentum of polymer chains, which makes the okay soften. The rubber we obtain on heating is called softened rubber. Initially, it was hardened. The polymer is hardened because of presence of intermolecular forces between the polymer chains or breakdown on heating. It produces the softened rubber. Here there is a no links between there is a no molecular intermolecular forces between these polymer chains. Okay, whatever the rubber we obtain by heating is called as softened rubber. Initially it was hardened. Okay, we got this softened rubber. Okay, these are those which are softened by heating. Softened by heating and hardened on cooling. Okay, if you cool this softened rubber, you will get back the same hard rubber. On cooling, the plastics, the intermolecular forces again reappear. Same thing. Okay, if you cool this, okay, whatever we got, no, if you cool this one, on cooling, on heating, we got the softened rubber. Again, you will get the hard rubber. Okay. Again, you will get the hard rubber here. The same on cooling, the plastics, the intermolecular forces reappear. Okay, intermolecular forces reappear, holding the polymer chain in the fixed position. Okay, fixed position which makes the rigid and hard. Okay, initially it was harder, on heating and cooling making softer. Okay, again if you cool, again you will get the same thing, reappear, holding the polymer chain in fixed position, which makes them rigid and hard rubber you will get it. Okay, here thermoplastics are generally prepared by addition polymerization. Already we have discussed in the differences between the addition polymerization and condensation polymerization. We discussed these thermoplastic resins are prepared by addition polymerization. Okay, thermosettings by condensation. Okay, condensation polymerization. Example, polyethylene, PE, polyethylene, polyvinyl chloride, polyvinyl chloride PVC, polystyrene, PTFE. The full form of PTFE is polytetrafluoroethylene, Teflon. We call it as Teflon. These are prepared by thermosetting. Okay, thermoplastics. These are thermoplastic resins, are nothing but those polymers resins which are softened by heating and hardened on cooling. Okay, what happening here is whatever the intermolecular forces present between the polymer chains are undergoes breakage and facilitate the monomer chains to easy momentum. Okay, easy momentum. Okay, which makes the polymer to be softened. When this softened rubber on cooling, it undergoes reappear there, holding the polymer chain in fixed position, which makes them rigid and hard. Rigid and hard. Thermoplastics are generally prepared by addition polymerization. Examples are polyethylene, polyvinyl chloride, polystyrene, and PTFE, polytetrafluoroethylene. Polytetrafluoroethylene, nothing but Teflon. Now coming to the second type of the resins, nothing but thermosetting resin. Thermoplastic is the first one. Thermosetting resins. Okay, here these are resins which during molding process, okay, molding gets hardened. Okay, latter cannot be softened. Okay, just opposite whatever we discussed in the thermoplastic resin, here during molding what happens means it get harder, but we cannot soften by heating. We cannot do this soften by heating the thermosetting plastics, thermosetting resins. Okay, here it possesses a three-dimensional structure, three-dimensional cross-linked network. Okay, here thermosetting plastics are possess the three-dimensional network. Three-dimensional network, and the chains are made up of covalent bonds. Here it is made up of covalent bonds. Whatever these strong covalent bonds are present. Okay, between the chains, the strong covalent bonds are present, which makes the resin to be stronger. Okay, even at very high temperature. Here, we have in the thermoplastic resin, weak covalent bonds are present. On heating, the covalent bonds are they undergo breakage and it forms the softened rubber. Again, on the softened rubber, on cooling, you will get the same process. Okay, hardened rubber. But here it is not happening like that. In the thermosetting resin, okay, the resins which are prepared by this thermosetting resins are okay, during the molding it gets hardened and we cannot do the soften by heating. We cannot do soften the thermosetting resin. The reason is because of presence of strong covalent bonds between the monomer chains. Okay, because of presence of covalent bonds, strong covalent bonds makes the strengthen the rubber polymer even at high temperatures. Okay, even at high temperatures. Examples of this thermosetting resins are okay. Here bakelite. Okay, bakelite. The bakelites are nothing but switchboards. Now switches are made up of this bakelite only. Okay, bakelite and the epoxy resins. All these are made up of, all these switches are made up of, okay, polymer, that is bakelite. Epoxy resins. Okay, what actually the thermosetting resins here? Resins which during molding process get hardened and later we cannot be softened by heating the polymer. And this thermosetting resins are three-dimensional network, three-dimensional cross-linked network polymer chains made up of covalent bonds. They are made up of covalent bonds. The strong covalent bonds maintain the strength of the polymer even at high temperature. Okay, even at high temperature, because of presence of strong covalent bond, it makes it strengthens the rubber. Okay, even at high temperatures. Examples for this thermosetting resins are, okay, uh, bakelite and epoxy resins. Bakelite and epoxy resins. Here, see, here in the thermoplastic resins, there are on heating. Okay, what it forms on heating, there is a no bonds are present. Okay, it helps to easy momentum. The no links between the polymer chains helps the easy momentum of this polymer chains. But in the here in the thermoplastic, okay, thermosetting plastics, links between the polymer chains stops the momentum. Okay, whatever the monomers are there, here it has strong covalent bond is present. Strong, okay, covalent bond is present, which helps to the strengthen the rubber. So there is a no momentum of monomers takes place, stops the momentum between them. Stops the momentum between them. Already the differences between the thermoplastic resin and thermosetting plastics. What are the differences? Coming to the thermoplastic resins, what actually the thermoplastics are usually formed by addition. Okay, same here, this is prepared by condensation polymerizations. Thermosetting plastics are prepared by condensation polymerization or step polymerization. Thermoplastics are usually formed by addition polymerization and it is formed by condensation polymerization. Here, it contains long chain linear polymer held together by weak van der Waals forces are present. Okay, here it contains a 3D network, three-dimensional network structure. Okay, this is a three-dimensional network structure with strong covalent bonds are present in the thermosetting plastics. Thermosetting plastics contain, okay, three-dimensional structure. Okay, it is a three-dimensional structure with strong covalent bonds are present. Three-dimensional structure with strong covalent bonds are present between the polymer chains. Here it is made up of weak van der Waals forces. Okay, here in the thermoplastic resins contain weak van der Waals forces are present. Okay, contains long chain linear polymers with held together by weak van der Waals forces. Okay, it is a 3D network structure constructed with strong covalent bonds. Strong covalent bonds. Okay, here already you know this. We can become usually become soften on heating and stiffen on cooling. Okay, already see you have seen this one. Okay, on heating the rubber, okay, thermoplastic resin, it become, okay, soft. Soft. Initially it was soft. On heating, what happening? It becomes soften on heating and stiffen on cooling. Harder on cooling. Stiffen means nothing but harder on cooling. It becomes harder on cooling. Soft on heating, harder on cooling. Okay, here it does not become soft on heating. It does not convert it into, okay, soft on heating. This is the thermoplastics are expensive. Okay, these thermoplastics are expensive, but thermosetting plastics are cheaper. Okay, they are cheap. Okay, now coming to thermoplastics is soluble in organic solvents. These are soluble in organic solvents. Okay, these are insoluble in organic solvents. And they are usually soft, weak, and less brittle in nature. Okay, but here it is hard, strong and more brittle in nature. Now we can remold. We can remold this thermoplastic resins, but we cannot remold because there are strong covalent bonds are present between the polymer chains. We cannot make into the remold this thermosetting plastics. Examples for this thermoplastic resins are thermoplastic is polythene. Polythene is example. The thermosettings they are bakelite. Example for is polythene, polyvinyl chloride, polystyrene. All these are the examples for the thermoplastics. But here it is okay. Thermosettings are okay. Example for thermosetting plastics is bakelite. This is the difference. One differences between thermoplastics and thermosetting plastics. Next, we'll discuss the compounding of plastics. How we are going to make. Okay, what are the additives added to polymer resin to make the? We can shape them into the desired form. Okay, what are the additives we are chemicals? Additives are nothing but chemicals required to for compounding of a plastics. Resins, plasticizers, fillers, lubricants, okay, catalysts, stabilizers, colorants we are going to add, make the desired shape of the resin. Okay, this is the differences between thermoplastic resin and thermosetting plastics. If you have any doubts, you can ask. Thermoplastic resins, thermoplastics are nothing but we can soft on heating and hard on cooling.
Sir, in CI topic it will come, sir.
Yeah.
In CI examination, up to which topic we study? We have to study.
Up to biodegradable. This is their classification of plastics. In 1 or 2 classes, I will complete this. Up to biodegradable, we have syllabus. Okay, these are important one. You may get one question. Only one question you will get from the module 3. Means whatever the discuss up to the biodegradable polymers. From module 1 and module 2, you will get 2 to long answers and one short answer from this polymer. One long answer from only one long answer you will get from the polymers.
Sir, exam third nunchena sir?
Exams fourth, third nunchi better kada, same third.
Sir, question bank could be enough, no, sir?
Yeah, enough. It's enough. More than enough. And the questions from the question bank only. You will get the questions from the question bank itself. There is no.
For the questions, we can't find answers in the PPTs. Should we just write them on our own doing?
You can whatever you're listening, no, you can write them your own. There is no problem. You can write also. Okay. Read the lecture notes. I sent the lecture notes, right? Module 1 and module 2.
Yes, sir.
Okay. From that, you can read. If you can write by your own also. Okay. If you understood the topic, you can write, but it should be the meaning mark. Don't write like as your own, because the chemistry, right? Okay. Whatever you understand by the topic, you can write from that. Okay.
Sir, offline or online mode, sir?
I don't know. Okay. You will get, if anything will be there, you will get in the Telegram message. Okay.
Bye, sir.
Maximum they are telling in the offline only. I don't know. Today there is a meeting with the minister, right? Today they will decide whether to conduct online or offline. If the classes, from 31st you have the classes, no, it will be offline only. There is no online class. It continues means it should be online. We'll discuss. You will get anything. You will get in the Telegram message.
Sir, COVID వస్తుంది కదా సార్ అందరికి maximum.
That is what they will decide. Okay.
మన కాలేజీలో గిట్ట కొంతమందికి.
Yes.
Sir.
చెప్పండి.
Sir, Q6 present, sir. Actually, I'm having power cuts. I'm attending from Q7 system.
Yeah, I didn't get you. I will take from this one from whatever your time it will show from that only I will take it. Okay.
Sir, but I'm attending classes from Q7 system because I have power cut, sir.
Okay. Your number is
Q6.
okay. I will see.
Thank you, sir.
Okay, ma'am. Stop sharing. In the next class we'll discuss. Okay. Thank you. Okay. Anything will be there. You will get the Telegram message, ma. Okay. Thank you, one and all.